Hi, everybody. Welcome to today's webinar. Today, we're going to talk about diving deep on running Active Directory on AWS. My name is Vinod Matabushi. I'm a solutions architect with AWS. I've been with AWS for over 4 years, and I've been working on Microsoft technologies for over 15 years. And today, I want to help you with running Active Directory on AWS, and that helps your Windows workload as well. Before we talk about deploying Active Directory on AWS, we're going to spend 2 minutes talking about why customers deploy Active Directory on AWS. A lot of you have Windows workload running on premises or in the cloud, and you're building new Windows workload. One of the big thing about Windows workload is Active Directory. A lot of these workloads require Active Directory, and that's one of the biggest reasons customers are deploying Active Directory on AWS. The second big reason is the latency. While you can run Active Directory on premises and continue to build Windows application on AWS, it's not the most ideal setup in terms of latency. Most applications require Active Directory to be close to where the applications are, and also you want resiliency in terms of the Active Directory architecture, and you don't want to rely on network all the time for Active Directory. So that's another reason why customers are deploying Active Directory on AWS. Lastly, you have a lot of AWS resources and services to manage, and you want to leverage your existing Active Directory groups and our users that you already have to control access to the AWS resources and services. And that's another reason why customers are deploying Active Directory on AWS. Okay, so before we dive into architecture, let's look at what are some of the choices for customers running Active Directory on AWS. The first way you can deploy Active Directory is through what we call self-managed on Amazon EC2 instances. So this is where you deploy an EC2 instance in a region and an availability zone that you like. And then you install the Active Directory package and make it a domain controller, and you deploy Active Directory. The second way you can run Active Directory on AWS is what we call AWS Managed Microsoft AD. So this is a service that AWS offers where AWS manages the infrastructure, like the domain controllers that are running the Active Directory, and customers are responsible for managing the data within the Active Directory. So today we're going to look at multiple architectural patterns that use both of these methods of running Active Directory on AWS, and we're going to dive more into why you should choose one over the other. Okay, so most customers ask us, how do I choose between these two options? And we see a common pattern emerging in why customers choose one or the other. Let's look at the first one. So why do customers deploy Active Directory on EC2 and manage it themselves? Well, one of the reasons is extending the existing domain or forest to AWS. So if you have a AD domain on premises and you want to use the same Active Directory domain on AWS to support your workloads, you have to deploy Active Directory on EC2. One of the reasons for this is because the AWS Managed AD does not support extending your domain. If you use the Managed AD, it's a separate domain from your existing domain, and that's one of the reasons why you would want to deploy this on EC2. The second reason we're hearing is control of the domain and enterprise admin privilege. So when you deploy AWS Managed AD, we give you what's called as a delegated rights. I'm going to talk more about that in the future slide, but you don't really get the enterprise or domain admin credential. So if there is a need for you to manage the credential, then you have to deploy AD on EC2 yourself. The third reason we hear is you want to use the same users groups and OUs, and you want to use them in both places. So this is possible if you deploy AD on EC2 because it's the same domain that you're extending. Lastly, customers who want a unified environment between on-premises and the AWS cloud, and they don't want to have two separate environments, deploy the AD on EC2 because that's the only way you can extend your existing domain and have the same domain service your applications no matter where the applications are running. Well, let's look at Managed AD as a resource domain. Why do customers choose this option, and what are some of the requirements that drive this option? Well, the first thing is some customers don't want to manage AD infrastructure. So they don't want to manage domain controllers. They don't want to patch them on a monthly basis, back them up, and manage the availability of the domain controllers. So this is a top reason why customers choose AWS Managed AD, because in that service, we manage all the basic infrastructure. You're only responsible for the Active Directory data. Some customers want to delegate the cloud Active Directory to a different team than the central Active Directory who maintain the basic user identity. If you have this requirement, then these customers are choosing AWS Managed AD because it's easy to delegate that directory, which is a separate directory from your on-premises identity. And you can set up a trust to kind of use both those directories rather than managing both yourself. Another big reason is delineation between on-prem and AWS environments. Some customers want a clear delineation between what's on premises and what's in the AWS cloud. And you can achieve this by using AWS Managed AD because it automatically becomes a separate domain. And you can then choose whether you need to have one or two-way trust or no trust at all, keeping them completely separate. So if your requirement calls for delineation of these environments, then you would choose AWS Managed AD. Lastly, if you need native integration with AWS services, such as AWS RDS, Amazon FSx, or single sign-on, then you would choose Managed AD as your preferred choice rather than running it on EC2. Okay, so what are some of the key features of AWS Managed AD? Well, number one, it's actually Microsoft AD. So this isn't AWS proprietary technology. This is Microsoft Active Directory that we manage and maintain for you that's running on Windows 2012 R2 domain controllers. The second reason is AWS Managed AD supports trust, which means that you can set up one or two-way trust with on-premises Active Directory or any other Active Directory running anywhere else, as long as there is a required network connectivity. And using the trust model, you can use the user accounts from on-premises on AWS and vice versa. The third is the group policy support. Most of you are familiar with group policies, and you probably use them extensively for a lot of things to manage your environment on a day-to-day basis. AWS Managed AD supports group policy just like you would in an on-premises AD. So you can do all of the same things like create group policy, assign to OU, and computers and user objects can have all these group policies. Seamless domain join. So this is a feature where when you launch EC2 instances, you can automatically have those EC2 instances join the Active Directory domain. So this is one of the big features customer like. So they don't have to have two-step process of launching an EC2 instance and then joining it to the domain. Availability and snapshots. So because we manage the infrastructure, we automatically design the Active Directory for high availability. We deploy 2 domain controllers across 2 availability zones at a minimum, and we automatically snapshot them on a nightly basis. So if there's any issues with Active Directory data, you can roll back the previous snapshot. Lastly, this all runs on AWS Managed Infrastructure. So this runs on EC2 infrastructure that's highly available, that has multi-AZ, that has robust network connectivity. So all of this AWS Managed AD runs on the AWS Managed Infrastructure, which gives you the reliability, availability, and the scale that you need to support your applications. Typical deployment patterns. So before we jump into Active Directory architecture, we won't go into all of the ways you can architect Active Directory. We're talking about 2 major ways we see customers deploy Active Directory on AWS, and we're going to dive into those 2 use cases and see how they're different. Okay, in this example, we're going to talk about extending your on-premises Active Directory on AWS running on EC2. So in this example, you can see that you have your corporate data center on the left, and you're running your own domain controllers. On the right, you can see a single AWS region where there's a number of your application servers and also some domain controllers. So in this architecture, you're going to create some EC2 instances and install the ADDS package on it, and then make it a domain controller of the same domain that you're running corporate data center in. Of course, you need some sort of network connectivity for the initial AD replication and ongoing replication. And you can choose AWS Direct Connect or VPN or any other network technology that you can use to connect the 2 networks. So let's talk about how things would work in this architecture. So let's say that you're running a 3-tier web app. So you can see the web servers here, app servers here, and the database servers here. Because this is the same domain as what your on-premise is, what you would do when you deploy these domain controllers, you would define sites and services within AD. So member servers in Active Directory detect where the domain controllers are based on sites and services. And because there are domain controllers in this AWS region, and you've defined this AWS region VPC as your site with the appropriate subnet, the web servers and app servers and database will use the local Active Directory for all authentication, group policy, and pretty much all the Active Directory traffic. The red dotted line you see here is the AD replication. So this is the native AD replication that happens between all domain controllers in your Active Directory environment. So that continues to exist no matter where your domain controllers are, whether it's in the corporate data center or it's on AWS. So let's say a remote admin wants to log into one of these web servers and manage the server. So the remote admin itself will authenticate to the local user through the domain controller and the corporate AD because they belong to the same site. But when that particular user RDPs to a web server, that authentication occurs to the domain controller in the AWS because of the sites and services. So in this design, you're able to unify this environment, have the same OUs, group policies, user and computer objects, and run your workload on AWS just like another data center or another site that you currently have. The second architecture we're going to talk about is where you're using AWS Managed AD as a resource domain. So a resource domain is a well-understood concept within Active Directory. A resource domain is where you keep your resource objects in a different domain from where your user objects are. So in this example, again, looking on the left, you see your corporate data center, you have your domain controllers running there. This is where your identities are. So a remote admin's user account would basically be located here. On the right, again, you see an AWS region, you see a number of web servers, app servers, and database servers, but these computer objects are located in the AWS Managed AD, which is a different domain compared to the Active Directory on the left. So if you have service accounts that you need for these applications, they would also be located in the AWS Managed AD. In this diagram, the red line here represents the one-way trust rather than a replication because there's no replication in a trust model. So in this example, we're showing a one-way trust where AWS Managed AD is trusting your on-premises Active Directory, but not vice versa. So what this allows you to do is it allows you to use your user identity from your on-premises Active Directory and log into any servers running on AWS without the data being replicated to AWS or AWS Active Directory. So again, let's take the same example again. So in this, if a remote admin wants to RDP to a server, he would first log in locally to his workstation, and that authentication would occur locally, on the on-premises AD, since that's local. But when he logs into the RDP or when he logs into the web server, that authentication still goes back to the on-premises AD because that user object doesn't exist in AWS Managed AD. So because of the way this works, you need a really robust network connectivity between on-premises and AWS region because this happens in real time. We recommend running AWS Direct Connect or VPN, but in a redundant fashion where there's a failover if there's an issue with a single Direct Connect or a single VPN tunnel. The applications still continue to run even if the network connectivity is not there because the computer objects are located in AWS Managed AD and the service accounts are located in AWS Managed AD. The only thing you wouldn't be able to do if there's a network connectivity issue is an admin logging into web servers to do something. All right, let's look at how we can expand this concept to more than one region. A lot of customers don't just operate in one region. They operate in multiple regions because they have a need to be close to the users or they have a need for a DR. So how would the Active Directory work in this example? So again, let's go through both the use case and talk about how this would work. So in the first example of you extending your Active Directory, you would treat each region as an Active Directory site, and you would place domain controllers in multiple subnet and multiple AZ in each of the regions. And if you look at the domain on the left and on both regions is company.local. It's because you're extending the same domain into multiple AWS regions, and all the domain controllers on AWS and on premises contain all of the replicated data for your single domain. Again, you need some sort of network connectivity at the beginning and in an ongoing basis to replicate those objects at the beginning and as you go along. If you were to replace that with an AWS Managed AD, the situation would be slightly different. In this example, we're showing two different domains in each region. The reason is the AWS Managed AD is a regional service, which means that today you cannot extend a AWS Managed AD domain across a region boundary. So if you are using AWS Managed AD as a resource domain and you want to be in more than one region, you would deploy a domain in each region. In this diagram, you can see that there's a domain called na.company.local and eu.company.local. So these are two separate AD domains that are managed by AWS as an AWS Managed AD that runs in the respective regions. Both of them have a one-way trust back to the domain controllers. So essentially, you get a delineation between objects that are regional in each of these cases. So if you have member servers in region 1, they would be member of the AWS Managed AD na.company.local. And if you have member servers in region 2, they would be a member of the second domain, eu.company.local. But both of them can have a one-way trust back to your domain controllers. So when your administrator is logging in to manage any of this, he still uses that single credentials that exist on the on-premises corporate AD to manage all of this. Again, the network connectivity requirements is the same. You would want to have a direct connect or VPN to connect. But like I mentioned before, in a resource domain situation, your network connectivity needs to be more robust because the authentication is real time and it's not cached. You want that to be available so you don't have an outage. You can't log into a member server because there's a network issue. Okay, let's talk briefly about internet name resolution. A lot of customers use their domain controllers as also DNS servers in the environment. Some customers don't. They use a different appliance or they use even Route 53 for that purpose. But irrespective of what you use, we want to show you how internet name resolution works if you're using a domain controller for DNS. So in this diagram, you can see multiple VPCs on the right and then a shared services VPC on the left. Essentially, our recommendation for running Active Directory is to centralize your Active Directory within a region in a single VPC. And there's a number of reasons for that. We're going to talk about it from a security perspective. But what happens in this case is you have a number of VPCs. Assume these are business units or even application VPCs where you're running your applications. And then you have domain controllers in a centralized VPC. And again, it doesn't have to be two domain controllers. You can deploy a number of domain controllers. Either it's AWS Managed AD or AD on EC2, doesn't matter. You can determine how many domain controllers you need to support your workload. So in this case, they're all pointing to the domain controllers for DNS, but the domain controllers need to access the internet for resolving internet names. And we have a number of ways of doing that. The first thing you can do is point the domain controllers to .2 resolver. So the .2 resolver are the resolvers that you get with every VPC, where you can point to .2 and we will resolve internet queries for you. The second way you can do the same thing is by using a NAT gateway. Because the domain controllers are not in public subnet and should not be in public subnet, we have a way for domain controllers to get to the internet to resolve internet names. And that's possible by putting a NAT gateway in a public subnet. The third way is running your own DNS server in a public subnet that allows recurring queries to be resolved without the domain controllers reaching out to the internet. Now, out of these three methods, the most preferred ones are using the .2 or deploying your own DNS servers. And there's one good reason for that. When you have NAT gateway, the domain controllers are still reaching out to an endpoint on the internet directly. So if there are any DNS vulnerabilities, there is a chance for your domain controllers to be exposed to that. Whereas in both the .2 case and the DNS server, you're exposing that DNS server or the .2 DNS server to the internet, but the domain controller is never making a direct connection to any name servers on the internet. So if you have opportunity to choose one, go with the .2 resolver or the DNS resolver. Those are the preferable ways to do this. Let's quickly talk about account structure. You're probably wondering how to deal with deploying Active Directory to support many of your business units and your applications. So in the previous slide, we talked about centralizing Active Directory to a single VPC per region, so you can support all the use case. But your next question is, which account should that VPC be in? So you may have heard about landing zone and/or control tower. So these are AWS services that help you manage multiple accounts and splitting the roles between all these accounts so you can scale your AWS resource as well without worrying about account and separation of duties. So similarly, we have established a account structure for Active Directory. So in this diagram, we're showing you an AWS master account, which is a master of the organization. We're also showing you a security account and a log archive account. So by default, things like guard duty or security tools are located in security account. And the log archive account is where all the logs go in. So similarly, we have a concept of Active Directory account. So it could either be a shared services account or a dedicated account for Active Directory. But you should separate the Active Directory from everything else, especially the business units, because that way it allows you to manage them centrally and control access to that very easily. And we're going to look at some of those in the future slides when we talk about security. All right, so let's talk about Active Directory security. What are some of the security best practices that you should follow when you're deploying Active Directory on AWS? Well, number one, centralize your AD in a single account. And we talked about why. It's easier to control access if it's in a separate account rather than trying to control access to AD from many people in a number of accounts where your business units are operating. You need to restrict access to EC2, EBS, or directory service based on how you're deploying your Active Directory. If you're running your own Active Directory on EC2, then EC2 and EBS becomes important. This is because you don't want to give anybody rights to snapshot EBS volume or have access to EBS volume that contains sensitive Active Directory data. The same way, you don't want to give anybody rights that shouldn't have that right to start, stop, or terminate a domain controller. So this is why it becomes critical to restrict access to EC2 and EBS to Active Directory administrators only. And this becomes very easy if you centralize Active Directory in an account on its own. Either it's a shared services or an Active Directory account, depends on how your organization is structured. Secondly, if you're using Active Directory in a managed fashion, then you don't need to worry about EC2 and EBS because they're not exposed to you. You only need to control access to the directory services. And again, making this Active Directory in a separate account allows you to control access easily to the directory service to the right set of people. Restricting security groups. So you all are aware of security groups and how it helps filter traffic to all your EC2 instances. We want you to use security group to allow only Active Directory ports that are required and only from the required networks. Well, what does that mean? So in the diagram that I showed you before, you had a number of VPCs where member servers were located, and you had a VPC where Active Directory was located. So if you are to configure that Active Directory, you should only open AD ports to all those VPCs where you have member server, or to domain controllers on premises or somewhere else where you need to establish trust. You don't want to leave the security group open to networks that don't require any access to Active Directory. This reduces your surface area of attack if there's a network attack at all in your network. Encryption. So we want you to encrypt EBS volumes at rest and in transit when possible. So it's really easy to encrypt EBS volumes by using AWS KMS or Key Management Service that allows you to encrypt data at rest. And if you're using Active Directory for other application, it's relatively simple to turn on LDAP-S, so your authentication traffic is encrypted even within the VPC. If you're using KMS to encrypt EBS volume, consider using a separate master key for Active Directory because that allows you to control access easily to who needs access to that master key and keeps that control of separation of who can decrypt that EBS volumes and snapshots that are encrypted with this customer master key. Security logs. So you guys must be familiar with security logs that DC generate. It has a wealth of information about what's occurring on your Active Directory and your identity in general. So monitor the security logs for anomaly. There's a number of tools, third-party tools out there where you can pump those security logs and get a lot of insights out of that. Consider setting up alerting for key security events. So these are events that's considered high risk or events that are unlikely to occur frequently or at a certain time of the day or even times of the week. So if you see these type of events, you should set up automatic alerting to your security team so they know to investigate further of why this is occurring. Administrative tasks. So logging into domain controllers to manage them is not really a good practice. So we recommend setting up a management server to perform all administrative tasks rather than logging into the domain controllers themselves. This increases your security and your auditability on who is performing what tasks. Okay, so we talked about Active Directory security, but let's dig in a little bit more on how does AWS Managed AD security work? Well, number one, AWS Managed AD is a single tenant, which means that when we deploy domain controllers for you, it only contains your data. It does not contain or co-locate any other customer's data. This doesn't mean the EC2 instances that are running as domain controllers are dedicated tenants. It just means that the Active Directory data that's running on EC2 instances are just your own. So we do most of the management tasks via automation. So when we, as a part of managing the Active Directory, we have a lot of automation around securely patching and securely rebooting your domain controllers in a monthly cycle. We also have a process for when human touch is required. So this is where, let's say, an automation didn't work and there's a human touch required by a support engineer. We have a process for that where an engineer is given a limited amount of time to perform only the administrative tasks that he needs to do to resolve that situation. We talked about domain admin credentials. So one thing you should know is AWS employees don't have access to your domain admin or enterprise admin credentials in an AWS Managed AD. These are under automated control. So as soon as we spin up your domain controllers, those automatically are vaulted in a vault that we maintain, and very limited folks have access to that. And they're all automated. Domain controller security logs are important, so we deliver them to the CloudWatch logs, so you can consume that from there and do all your analysis and also real-time reporting as required. Lastly, delegated administrative access using predefined groups. Because we don't give you the enterprise or domain admin credentials, we pre-create a number of groups or users and OUs where we give you a delegated rights. The rights allows you to use the Active Directory, so it gives you permission to create OUs, create users, groups, manage group policies, and so on, without giving you the full domain admin or enterprise credentials. This is required for us to securely operate the service and be highly available and scalable at the same time. Lastly, you cannot RDP to the domain controllers if you're running AWS Managed AD. You have to use a management server for all admin tasks because RDP access to domain controllers is blocked. We talked about how the name resolution options are available for you when you're using domain controllers or DNS. In AWS Managed AD, we automatically use the .to resolver for all internet-bound queries. So that's how we manage the name resolution. When it comes to encryption, our EBS volumes and snapshots are by default encrypted all the time, and they're using KMS for doing the same thing. In terms of LDAPS, AWS Managed AD supports LDAPS. It's not turned on out of the box because we need a certificate server before LDAPS can be turned on. But there's a link right here that you can refer to where you can go and follow the instructions step by step to set up your AD certificate services and turn on LDAPS for your AWS Managed AD. Okay, so we want to talk about AWS Managed AD shared responsibility. Because AWS is managing the Active Directory infrastructure and you're managing data, there's a shared responsibility between who is responsible for what. If you look on your left, you will see that AWS is responsible for all the heavy lifting of the infrastructure and operating the Active Directory. For example, protecting the hardware software that runs the AD, isolation of domain controller between customers, protecting your domain admin credentials, encrypting EBS volume, managing snapshots, and so on. On the right, you can see all the tasks you are responsible for. This pertains to your Active Directory data. For example, users, groups, and OUs, you're responsible for creating and managing them. Similarly, you're responsible for managing trusts, if you have any, and of course, managing the connectivity from Active Directory to all your member servers and managing that network connectivity. We allow for schema extension, but you are responsible for providing a compatible LDIF file for those schema extension. We also support Radius and MFA to be integrated with Managed AD. Again, you're responsible for management of this infrastructure and configuring the integration between the two. Lastly, if you need more than 2 domain controllers, you can certainly launch a number of domain controllers to support your use case. And you can do that in the console based on the number of domain controllers you need based on the load. All right, so that's the end of the presentation deck. Now we're going to show you how easy it is and quick it is to deploy AWS Managed AD in our AWS Console. And after we do that, I'm also going to show you how to deploy a management server and log into the management server to do basic administrative tasks into the AWS Managed AD. Okay, now I'm going to log into my AWS Console and then launch AWS Managed AD. So you can see that I'm already in the AWS Managed Console. I'm going to go search for AWS Directory Service. So the AWS Directory Service is where we can deploy new domain controllers. You can see that I already have a AWS Managed Microsoft AD called test.local. And the reason I've already deployed this is it takes about 20 to 30 minutes to deploy the AWS Managed AD after you start it. So I want to make sure that I have a directory to demonstrate the other pieces of this demo without waiting for this. But let's go ahead and set up a new AWS Managed AD so you can see the steps. So when you're here in this, click on Setup Directory, and there's a number of options here, but I'm going to pick AWS Managed AD, and then click Next. So you have two choices available in terms of edition. You have a standard edition and you have an enterprise edition. The big difference between the two is the amount of storage you get in terms of directory objects. So the standard comes with 1 GB of storage, and the enterprise comes with 17. So based on your requirements on how many objects approximately you might store, or based on your estimation, you can pick one or the other. Today we're going to pick the standard edition. So other than the storage size, there's really not any difference between the two in terms of feature. So the next thing we're going to do is type in a directory name. So for example, in this one, I'm going to call this directory test-ad.local, and I'm going to keep the NetBIOS name as test-ad. And I also can provide a description here. So if you have multiple directories you're using for different purpose, the description may come handy and it might be helpful. So I'm going to call it, this is my test AWS Managed AD. All right, admin password. So two things you want to note here. One is, by default, we call this user admin. It's not the administrator, which is the enterprise/domain admin that is under AWS's vaults control. So make sure to remember that your username is admin. Secondly, this is the admin password that you're going to create when we create the directory. So this is the password you have to use the first time to log into the directory. And then from that point on, you can create more administrative users and or groups for all your future purposes. So I'm going to go ahead and create a password here, and also confirm the password, okay? And then let's go ahead and click on Next. All right, so VPC and subnets. So before you deploy AWS Managed AD, you need to have VPCs and subnets pre-created where you want to deploy them. As I talked about in the deck, you don't want to deploy AWS Managed AD in a public subnet. You want it to be in a private subnet. So for the purposes of this demo, I've already created a VPC called Active Directory VPC, and my subnet there is the 10/16. So I'm going to go ahead and select that. And I have multiple subnets that I've already created. You can see that I have 3 subnets. I have Active Directory private subnet in AZ1, and a private subnet in AZ2, and a public subnet in AZ1. So for the purpose of deploying this directory, we're going to select 2 private subnets. So I'm going to create the AZ1 and the AZ2. Both of these are in different availability zone, and that's definitely a requirement so that you get that high availability from single AZ. Let's go ahead and click Next here. Finally, you want to review everything and click on Create Directory. So we made sure that the DNS name looks right, the NetBIOS name looks right, and I'm deploying them in all the right subnets and the VPC. So I'm going to go ahead and click on Create Directory. So as soon as you do that, you can see in the console that the status has moved to creating, and it would take about 20 to 30 minutes to create. But once it's done, you would see the status active. That means that your directory is deployed. So if I click on this directory, you can see some of the information. For example, you can see that the directory ID is this, and then you have the directory name. You also see these 2 DNS addresses. So these are the DNS addresses that you would use as DNS servers. And these are also addresses of the domain controllers where your DCs are actually running for this particular Active Directory. And you can see the availability zones. So I have 2 AZs, US East 2A and 2B. So what I'm going to do next is I'm going to deploy a management server, and I'm going to seamlessly domain join that to this directory. And then we can try to log into that and manage this directory. So let's go over to the EC2 service. And then what I'm going to do is I'm going to create, click on Launch Instance, and I'm going to create a Windows server. I'm going to select the 2019 base. You can select the size based on your requirements. I'm going to select the T2 Micro. Okay, so a couple of things here. The first thing is you have to deploy this in a VPC that has connectivity to the AWS Managed AD. It doesn't have to be in the same VPC. But for the purpose of this demo, I'm going to deploy it in the same VPC. but I'm going to deploy it in a public subnet because I'm going to use this management server as both a bastion host to log in from the internet and also to manage AD. If you had a VPN or direct connect between your AWS network and your on-premises, you wouldn't need a bastion host. You would place this management server in a private subnet rather than public, because you can reach that through the VPN or direct connect rather than from the internet. I'm also going to enable the auto-assign public IP. So when I select this, my instance will automatically get assigned a public IP dynamically when the instance come online. And I'm also going to domain join this to the existing directory that I've already set up. So if I scroll down, I can see the two directories that we launched. The test-AD is still under creation, but the test.local is active. So I'm going to go ahead and select that. It requires an IAM role, which I've already created. So I'm going to select the domain join EC2 role. So before you can domain join an instance to a directory, you need to create this role. And once you have that role, you can use that role for all subsequent domain join. I'm going to leave the storage as is. And for the tag, I'm going to call this AD management server. And I've already pre-created a security group. It basically allows RDP from my IP. So if you see, I'm only allowing RDP from the internet. I'm only allowing that from a single IP address, which is mine. So this allows your bastion host to be secure from everybody else on the internet. At the same time, allow you to log in securely from over the internet through RDP and manage your Active Directory. Finally, I'm going to click on Launch. This is going to ask for an existing key pair or create a new one if you don't have one. I already have a key pair for this Ohio region, so I'm going to select that I have access to this key pair and click on Launch Instance. So it takes about a minute or two to launch this particular instance, and you can see the list of your instances by clicking on View Instance. You can see that the AD management server is in the pending state, so it'll take a few minutes for us to access this server. And when you click on this, you can see the public IP address that the server is assigned. So what I'm going to do is I'm going to use this public IP address and log into the server and perform any administrative function. Okay, as you can see now, the AD management server is in the running state, and we're going to take this public IP address and we're going to RDP to this. I've already taken this IP and put it in my RDP client. So I'm going to double click on this. When I'm logging into this, I'm going to use my admin credential that I created when I deployed the managed AD. So this would be in the format of your domain name / the username, which is admin, and then the same password that I used when I created the AWS Managed AD. So when I do this, I'm logging into this workstation or management server as the admin, and this management server is already a part of the domain because we seamlessly added this to the domain when the instance was launched. One other thing that I did was I installed the ADDS management tools so that we don't have to wait for the tools to be installed and you could see how the management works. So once I'm logged in, I can open the Windows administrative tools. You can see I've installed the basic tools like the ADUC and the DNS. So if I open the ADUC, you can see the domain. So you can see the test.local domain that I'm already logged in, and you can see some delegated groups, right? And you also see the OUs and the OUs and the users that we have already created for you. So that's it. That's the end of the demo. So this is how easy it is to deploy your AWS Managed AD and start administering that, within 30 minutes. So with that, thank you for attending this webinar, and let me know if you have any questions.